Good morning and welcome to day 2 of Mastering Your Data track. Now, I've had a lot of fun pulling this track together. So when I go and talk to customers, I have a list of modernization type topics I like to go through. So data mesh, tick, data strategy, tick. And today we tick the box for moving from batch to streaming. So just before I hand over to Ingrid, just a couple of requests from you. Please check in your app. There's a survey menu. You can go back and record your reviews for yesterday's sessions, and please review the session today as well. It really helps us when we pull together the content and the planning, and how we can make things better for you. So that's me done. Over to Ingrid.
Thank you, David. I hope you can hear me well. I'm very excited to be here and share about RBI's journey from batch processing into the data streaming world and into the data product direction. So it's still a bit data mesh. So let me first introduce who we are, who is RBI. So we are international banking group. We do our business mainly in Central and European Europe. So we have more than 250 banks within the group and 50 million customers, around 50,000 employees, and our headquarter is in wonderful Vienna. So how do we start today? What is the current architecture? And if you remember the number of 250 banks, you can imagine the data integration is a major challenge. So these banks have different source systems all over the place. We're talking about hundreds of different source systems. And our enterprise data warehouse, which we run on Teradata, has the main purpose to deliver data for bank steering purposes. So we deliver data to risk, regulatory, and finance. So let's start from left to right. So we have on the left side, we have in our countries, in all our network units, we have our different source systems. Each country, as mentioned, is different. We have central teams which are doing translation from the source taxonomy into a local warehouse taxonomy. So what you see here is not the number of local warehouses, it's the number of local warehouses patterns. So we, in head office, we use the warehouse on Teradata already. So here we did it more right. So we already transform our source data into our group taxonomy. I will explain in a minute what this is exactly about. In our network banks, we have a variety of different local warehouses. The one pattern is we have a central solution, which is the so-called group data warehouse. So their source taxonomy is translated into a group taxonomy. We have other units which have their own solution, their own warehouse solution. So again, central teams translating source taxonomy into another local warehouse taxonomy. And we have also units, they have both. And then we have a bunch of very small units, and they send their data already translated from source into a group taxonomy. We use ESIF as an interface to get the data into the warehouse. And actually the good thing about ESIF is we do not need to do any transformation anymore because it's already in the right taxonomy. And once it is in Teradata, it's then again translated from central teams to the data producers, and then it's picked up by our consumers into the analytical process. So you might see we have a lot of central teams. You might imagine in which direction the journey is going. So I told you I will talk a bit about this ESIF thing in the middle. When we started with our enterprise data warehouse implementation more than 10 years ago, there was the decision done that we will have a business data model. So that's a model governed by business. So here we talk about loans, local customers, collaterals, and how they are related to each other. And this is really done by business. So this has descriptions, this has flags, this has domains, and that's a really business governed model. And out of this business data model, we generate ESIF. So it's a structured interface specification. We can provide this in an Excel format, but also in a technical format. So we do this also as a JSON format, which can be picked up by automatic processes. So this has some aspects of a data contract, but not fully. The purpose, of course, of ESIF is to get the data from the network banks to the head office and to give the units the possibility to deliver in the common language. The process and ESIF is then also governed and based on this RBI business data model. And I also share with you a bit about the facts and numbers so that you get the feeling how big this is. So at the moment, ESIF, which is a subset of the business data model, has more than 200 files. It has more than 7,000 attributes. And depending on the portfolio, each network bank delivers between 50 and 120 of these files daily and monthly. We also distinguish between Ultimo processing and daily processing. So we have on the Ultimo retail and non-retail data inside. On the daily, it's only non-retail. And it's about 2,000 files for a delivery and 1 billion of records. To send or to support this process, we also have a release and a testing process around this ESIF. So we release new ESIF versions every quarter. So there we extend with new attributes. Every month, unit can add new data to ESIF, and this is tested in centralized test cycles. So the whole change until the consumer is verified, checked, and make sure that the data quality is good. Because we are talking here about a regulatory process. So there is no room for doing things not right. So business is sitting in our necks and the regulator even more. So there's a lot of really good things in this whole, in this process, in this setup. And it was good when our requirement was, let's deliver once a month the data, but times have changed. So why do we have to change? And I will point out 3 main problems. So the first problem is this data integration with central teams is not scaling anymore. So our organization in head office alone has already 120 people. So in the network banks, we have more central teams. They have to work on data integration topics. They have to work on platform topics. These innovation cycles take too long, and business is also not happy about that. So in a new architecture design, what we need to take care of is that we move transformation efforts away from the central teams and move it closer to the data producers and to the data consumers. And also to remove these layers in between, because now a new requirement has to be implemented in the enterprise data warehouse, in ESIF, but also in the local warehouse and in the sourcing. So that's too complex. The second point is the latency goal. So we have to do full warehouse integration locally, then we generate the ESIF, then we have another load which is standardized, but still into the enterprise data warehouse, and then we transform the data into the consumer taxonomy. Our requirement is to deliver daily data T+1 in the morning before business is starting. At the moment, what we can achieve with that, T+2 in the afternoon. It's not faster. And we only talk about non-retail data, not retail, and we have this as a clear requirement. So what we have to do is we need to remove the local warehouse layer from the group data integration process. We need to change from batch into streaming. And we also have to get rid of our full delivery and change to data. And the last point, that's actually my favorite, is data quality and ownership. Sounds familiar, I guess. So what happens at the moment, we have a consumer which has to talk to his central team, explain the requirement. Then the central team talks to the next central team. Until this is translated to the source system, it's very complex and it's time consuming. Also in case of data quality, it's impossible to find out actually who's the contributor of this field, because we have wallpapers of mappings which are doing all these translation steps. So what we need to do in a new architecture design, we have to create data products, reuse the ESIF taxonomy, and move the responsibility to the data producer. I even do not blame the data producers that they cannot take over responsibility because they deliver their perfect source data, but they have no control over all the layers which are happening afterwards. We have to move translation or transformation directly from source into the data products without all these hops in between. And what we also need to do is we need a central validation service which takes over, which provides us an overview on the quality and do this based on our common group taxonomy. So these are our main issues. There are more, but I think we do not have so much time. So how would this transition look like? So that's our starting point. So first, we have to remove the local warehouses from our group data integration process. This does not mean that locally we don't need warehouses anymore, but we cannot afford doing this via the full-blown integration process. What we also have to do, we have to distribute the central teams into integration teams which are closer to the data producers, in the very best case, directly to the data producer. And we have to do the same thing on the consumer side. So instead of having a central team serving our consumers and doing translation efforts, here is our group and common taxonomy, take over the responsibility and do it yourself. And actually the consumers, they would like to do that. So we are not sure if they know what they would need to also take over in terms of responsibility, but they are actually eager to do so. So what we do in the middle, because you can maybe still remember we have on the 2000 ASI files for a delivery. If we multiply this with all the source systems, we get a lot of data products. And again, we have a regulatory process. So we need to make sure that this works out well. So we need a kind of platform which is doing group data integration or group data aggregation. So what we develop in RBI is an internal platform, which we call eHive. So it has nothing to do with the Hive catalog, but it's our name. And here we'll use streaming. So the requirement to the data producers will be in the future, okay, that's easy, if that's your specification. Please provide us the data already translated in the group taxonomy. And we will send this further to the enterprise data warehouse. We do this by changing to service architecture. So instead of having big monoliths, we have an agent which is doing the collection of the data products, aggregating them together and pushing them forward. And we also have some validation processes on top of it. And what we also need is we need a small persistence layer. That's not a warehouse, that's important, which is storing for a few days the data which is sent to do this validation and also to do delta calculation. So how is this now addressing our initial pain points? So first, we have separated data integration from platform innovation. So we have decentralized teams which will be responsible to deliver data products in the right taxonomy. We have the same thing on the data consumer side. And we can finally also focus on doing platform innovation. So the usual conflict, business demand is more important than platform innovation demands, is we can resolve with this. We can talk about Vantage Cloud Lake and features on Teradata and separate here clearly the responsibilities. Next is we got rid of all dispatch integration processes and have changed to a service architecture, which is a lot more flexible and is also extendable. So we are finally in position to achieve the latency goals. And again, coming to my favorite point, now our data producer is talking in our group taxonomy language, same as our data consumer, and they can ask requirements in a common language, but also they can discuss about data quality issues because we know exactly from which data product, which data element is coming. So the consumers are enabled to do this directly with the data producers. Sounds perfect and super easy on PowerPoint. But not, let's come to reality. So what is the step one? And here the ugly truth is, before it gets better, it will get worse. So our first step is, okay, we add another layer. So the first step is to put in this eHive platform. We are in a good situation that ASIF is existing already. This is something we get every day, every month, already delivered by the network units, and we just take this, reuse it, and put it to the new architecture. So what we gain by this step is that we learn about the new platform. We connect the enterprise data warehouse to the streaming. We have then a local validation service in place, which we can also extend if we have a newer need or more need. And we'll also tackle in this platform that we move from full to delta. So we can still receive full via ASIF, but we will process in the enterprise data warehouse only the delta. And this gives us much more flexibility also for our correction processes. We do not have to process 100 million records for a correction load. And only as a second step is we start moving the inbound part into the data product. So, and this is for sure the much bigger challenge. On the right side, that's an architect, it's an engineering challenge. Still a challenge, but this one is more related to governance, to change in the whole organization, to convince our data producers to actually deliver data products. What does it mean exactly? To help them with technology to do it in an efficient way. And it's a huge effort for all our network units. So then we also have for quite some time, and we talk about years in this perspective, we will have this hybrid situation so that we start moving into data products and still can rely on the existing ASIF delivery. To help a bit the units with this migration, we want to automate this a bit. So again, we are in the lucky situation, ASIF is existing, so we have a clear reference. We have a source, we have a ASIF delivery, so we know exactly what we expect in the data product, and this is really a benefit. So what we can do in an automatic way is we can do a direct mapping and compare it with the existing ASIF delivery. And to make it even more efficient, we have tried manually for once to use also a large language model to do so. So we have taken source data, target data, sample. We have added the description of the source, the description of the target, and asked ChatGPT, please provide me a transformation script from A to B. And it took a few iterations. So first records counts were wrong. We gave some feedback back, saying, okay, this is not correct. These records are not missing. And we did some iterations until the record counts were matching. Then we focused on the attributes, and we finally did this. So this was an easy example, and it was for sure not faster than if you do it manually. But if you can automate the process of prompting, then we assume this could be really a big help. And even if we do not, so we do not expect to reach 100% and we can automate this, but even if this is 40, 50, 60, based on the amount of migration we have to do, it will be a big saving for the unit. And also we learn the units how to do the automated process. Good. I don't know if we have some engineers also in the room, but usually what technologies are we using? So our service architecture we have implemented on Java using Spring Framework. For the streaming, we use Pulsar. Internally we call it Neuron. We run this thing on Kubernetes clusters. We have 3 different types of persistence layers. So one, as mentioned before, we use to store the data for a bit. So this we do on Postgres. We store our validation results in MongoDB. And we also need to orchestrate this whole aggregation process. So for this, we use Neo4j. And we also have two UIs, one to share the local validation results with the units, and one UI to observe the process. And for this, we use Angular. And yeah, of course, we use GitHub and an internal product to build our pipelines and to store our repositories. Good. So what are our challenges? I've separated this between architecture and organizational challenges. So the first challenge was because we and the team, we started with all these data warehouse guys working for years with batch processing. So it took us some time to come up with the right architecture and to go into the streaming world. So when I joined the team, the ideas were still on let's implement the converter and things like that. And after really some discussions and going in different directions, we say, okay, let's go into streaming. We assume that for quite some time we'll still have batch over streaming because our sources are not capable of doing real streaming, but we do not limit ourselves. So we have the potential to grow into something future without redoing everything. Then we also had the phase when we wanted to go wild. Let's get rid of the state. Let's do only streaming. Also not a good idea. Our use case is end of day. It's regulatory reporting. So we need to have a state. So that's why we came up with this architecture. Then what is important and was always for us important is automation. We don't want to code anything manually, so we needed to come up with an architecture which can handle these 1,000 data products. So what we do now is a fully automatic process. So we have our ISO specification, that's a software artifact, and our agents just pick up the latest ISO specification and they know exactly what to do. If we have a new version, new ISO specification, no need to change on the software. But this really took some time to come up with a good architecture. Also to create a transition architecture with a little sunken cost. So yeah, for sure, the stage converter on the old architecture would have been maybe a faster idea, but actually I think it would have been more expensive. The drawback of doing something completely new is it takes a bit more time. So there is not one single software component which was there before. So we have new runtime environment, the streaming, everything is new. So it takes a bit more time, but I think in terms of transition architecture, that's the better choice. And also we had to connect the old and the new world because again, it's an existing process. We have this ASIF loader already. We cannot renew this totally. This would be a huge effort. So we needed to come up with something which is then fitting to existing inbound process on the enterprise data warehouse. We also had to connect with UC4, which is still in place. Same thing on the inbound side. So this was also a challenge, but I think that's settled. The biggest challenge from architecture point of view is the last one. So we had the idea of being super flexible and doing orchestration also via streaming. So we use the streaming not only for sending data, we also use it to tell the agent what needs to be done. So we send out a context, that's the workflow in general. Everyone knows what's to be done. We send out a message and say, now it's time to do it. And everyone has his own share and they know what to do. That's a distributed event-driven orchestration. This took us a while. Now it's relatively cool. We will hopefully have to go live in November. Yeah, but this was really a bigger effort. Let's come to the organizational challenges. The first one is the time it takes to implement this change. So we are talking about several years. So even in this time when we started or we implement the first phase, already now the management changed. So we got the requirements from someone else who is now in charge. So we need to make sure that we are not moving. We have changed from Kafka to Pulsar. So we also have to catch up. And What we cannot do is we cannot stop in the middle. If we implement this and stop before we have done the migration to the data products, it will be worse. So I think that's the biggest challenge, and we can only tackle this if we have the full management support, which we have. But that's, for me, it's one of the biggest risks. Then, ASIF data products. We have in the organization already other discussions about data products. Domains who would like to do data products, to define their data models and so on. So ASIF is a bit a contradiction, or maybe not. So here we are also not so sure. But for me, the ASIF is a consumer-aligned data product. We have governance, and we have to do this, and we have to follow this one. But we have ongoing discussions on, okay, what exactly is the data product? Does it fit to the overall concept? So that's another challenge to be solved. One big challenge will be to move the ownership to the data producers, because so far they are super happy. They deliver the source file on the share and job done. Now they need to do translation. They need to take over ownership. They need to be approachable if the data quality is not wrong. So if I would be a data producer, I would say, no thanks. So we need to come up with something what is rewarding. But if you turn the story maybe a bit different, if I'm as a business owner of a loan system, my job is not done if I have sold the loan to the customer. My job is done if it's booked properly in my accounting system, and it's also only done if my loan is reported properly to the regulator. And I think this is something which will be hard to explain. And comes together with the next point, explaining why decentralized is now better than centralized. We have explained the last decades, let's go for centralized solution, everything is great, and now we want to decentralize again. So lots of interesting but challenging discussions. The last one is maybe only relevant for us. I told in the beginning we have to decommission, to remove these local warehouses out of the group data integration process. We have a product in place which is centrally developed, and it's developed since 20 years, so there is a lot of emotion attached on this one. Also, if something is in place for 20 years, it's connected to the infrastructure a lot. So to get this out, this will be, a challenge. Good. Wrapping it up. So we built eHive to address the current pain points. And we use data products. So this new architecture should really take care as a platform to get all these new data products and deliver this in the good quality as we do now and as we require. It will help us to grow from the existing world into something new. And we can only do this because we can reuse the existing group taxonomy process, because we have a business data model and because we have ASIF. And also we can develop from our monoliths, having the big batch processes, into a flexible service architecture. And honestly saying, we still have many more challenges in front of us than we have solved at this point. This was it from my side. Happy to answer your questions. Thanks a lot.
So whilst I give Ingrid a moment to catch her breath, just a quick reminder, please rate the session in the app, and Albert has a microphone, so if you have a question, please raise your hand and we'll get the question asked.
It's got to be quick, is it? Okay. I've got so many questions, but I won't be greedy. Your group taxonomy, is that informed by an industry standard model, or is that homegrown?
The business data model?
Yeah.
No, this was actually developed by business, so that's not on any industry model.
Okay. So it's kind of a in-house, yeah.
Yes.
Next question.
With so many layers to change, like how did you deal with the BAU enhancements or along with the way you are doing this change? There is enhancements being requested by business. How did you deal with those kind of projects?
Can you repeat the question? Sorry.
Yeah, I'll repeat it, Ingrid. So the question was, with your strategic program running, how do you deal with all the other BAU enhancement requests with the existing processes as well? So how do you run the two side by side?
So on the development of the model and ASIF, there is no change because we use both. And as we'll migrate, we have for some time to implement changes in both worlds. But we will find out a strategy to move really full blocks into the new model so that we reduce this time as much as possible. Also, what we are trying to do is what we plan to do is to set up a rollout team, which is helping the units to set up the migration process so that this is done in a relatively shorter period. So we'll come up with a boilerplate to do this. We'll come up with this migration process. So we try to reduce this time frame so that this double development is as little as possible.
Any other questions?
Can you give us a little more detail on the AI transformation components that you've got there? You mentioned you've got a target and a source models and sample data, but what is that producing? Is it producing SQL? Is it Java code? That kind of stuff. Maybe just a little bit more on that.
Yes, this will produce SQL code, so transformation scripts. But it could potentially do also something different. But it will be definitely something like SQL. What we also have in the organization on creating the data products, there's also some initiative how to create the data products. So we are, in the company, we have Databricks very strong. So the idea is maybe to build these data products on Databricks. We also initially came up with the idea it would be also possible to create an agent for that one. But it will be SQL because we have structured source data. We have to deliver structured source data. So SQL will be the most probable, most probable format.
Any other questions? Andrea?
Now I'm curious.
Yeah, me too.
So I'm also from RBI. So this is an internal question. Just everybody knows. What's the timeline until we are real-time streaming? And just in context, so we started this initiative about 1 year ago from a full implementation standard.
Yeah, so we started a bit more than a year ago, but I think since 1 year we know the architecture, let's say it that way. So in November we plan to roll out this model 1. And next year we will start with one pilot unit to move into this data product, and we expect that we'll learn a lot of this. But what I have to say, this will not be real-time streaming unless the sources can provide real-time streaming. And I think for our use case, it's maybe also not so important. I think it would be still good to go for real-time streaming because at the moment, I said in the beginning, our warehouse is mainly used for regulatory reporting. So we don't have our all these fancy use cases like marketing and whatsoever. And the reason is because it's too old data. It's not usable. So they are getting the data from any other channels. But if we have all this data integrated, and there's a lot of good data in the morning T+1, we might get more use cases also on the enterprise data warehouse, and also have the option to build other data products on top of the enterprise data warehouse, or take them directly from the stream. We have then much more options because we finally know from where the data is coming. We have the quality ensured, we have the governance there, So it gives us a lot more option. I think streaming for us is on the first place the data transportation, but we are not limiting us in the future.
Did you actually answer my question?
Yes.
About another year?
So in November we start with the Model 1, and then I would assume it's about 5 years until we are fully done with the transition.
Thank you. So I think we've still got time for one more question. Phil, did you have any other questions you wanted to ask?
So I think I heard your answer, but just with your vision for the data products at the consumer end of things, are you planning still to leverage your enterprise data warehouse as a source to provision those?
So that's not 100% clear
Okay.
At this point in time. There are some other movements in the company. Again, Databricks are very strong in the position, but for the regulatory purpose, we need this in the enterprise data warehouse. But I think also with the open table formats, I think we have many more options, but yeah, it's not yet decided.
Yeah, thank you.
Any more questions? Last chance. Okay, so Ingrid, thank you for a very compelling presentation.